Hello, I'm Rebecca the Maths Lady, and in this video I'm going to explain all about how we teach children about perimeter. We'll look at the mechanics of how we teach them to understand and find perimeters, and then we'll talk about formulas for perimeter and how children discover and use those, and finally we'll explain a little bit about the trundle wheel. This video follows straight on from the previous video about measuring length, and it is a good idea to have done some work on measuring length before we get into perimeter. Okay, let's get started. So children need a clear definition of perimeter because it's not a logical word, it's one of those words that could be anything, and in different languages it will be a different word. Perimeter is the distance around the outside of a shape. It's a measurement of a line that goes around the outside of a shape. If you're going to find any logic in that, you might have somewhere where there's a perimeter fence. And if children have come across that experience or that vocabulary, it's worth drawing attention to that and making the link. Even if you don't think your children have come across that vocabulary, it's worth asking them, has anyone ever heard of a perimeter fence? Because it's so nice and powerful to build from a real life experience that children have, and they love bringing their outside world into the classroom and connecting it to the maths of the classroom. It's a deep and powerful thing to do. So once everyone's got the idea of what we're doing with perimeter, then you need to get going with some work. I've created this simple worksheet here. These are some of the shapes from the first video on two-dimensional shape, and it's a great chance to rehearse their names, and of course you can ask the children, and they can get going with measuring the perimeters of these shapes one side at a time, adding the decimal measurements together, or the measurements in millimeters or centimeters and millimeters, and puzzling out the total perimeter of each shape. So that will generally be done with a ruler. You can start to see if there's any reasoning going on. This is a regular octagon. So do they really need to measure every side? And then I've just popped this in the corner. This worksheet will be free to download in all the usual places that you can find at www.authenticmaths.co.uk/worksheets. So what do they do when they get to here? You'll have all these children who are happily measuring away and puzzling out good answers, and then they get to here. And it's a great idea just to challenge them. Who can get the most accurate measurement? See what they come up with. They might try to use a flexible measure tape. That's actually really difficult because it doesn't bend in the right way. They may try to do it with a ruler. It's interesting to watch. But it's easiest to do it with a bit of string or a cord that you carefully match to wrap around the shape, cut to length, and then measure with your ruler. The other type of shape you come across when you're teaching perimeter that's mentioned in curriculums that wasn't in the two-dimensional shape video are shapes called rectilinear shapes, and they are just shapes where all the angles are right angles. So it's easy to draw them on a grid. They might be shapes, for example, like this. This is a rectilinear shape. And if this was centimetre squared paper, children could actually count the perimeter, not necessarily measuring it with a ruler, but it's useful to have one to hand because some children might start counting squares and you need to draw their attention back to the idea that they're measuring the edges of the shape. And you can also set children challenges where you give them a perimeter and they have to draw a rectilinear shape with that perimeter. They'll really struggle if you give them perimeters that are odd numbers. And you can give credit, rewards, prizes for the most interesting shape as well as for getting the answers right. So once everyone's got the hang of this, you can set your children to work to find perimeters of interesting things in the classroom, maybe some outside challenges too. You may find things like, here's a triangle biscuit cutter. They might find the perimeter of that. They might find the perimeter of their table. And there, I just wanted to mention something. If you're working with a meter rule or another ruler, if you notice, this meter rule has the numbers in the spaces. That's useful for very young children who are not yet working with a number line. But if you've got rulers in your classroom that are set out in this way, you want to get rid of them now. Children should be working with rulers where the numbers are on the lines. So there are plenty of opportunities for creative measuring here. And you can work with craft and design exercises as well. If children cut a piece of fabric to make a cushion or something and they want to add a border, then the border is the perimeter. And the key thing to understand here is that the object inside the perimeter, or the shape, covers two-dimensional space, but perimeter is a one-dimensional line measure. That's a big idea, and I'm going to come back to it in the video on volume, where we're going to contrast one-dimensional measurements, two-dimensional measurements and three-dimensional measurements, because it actually becomes easier to understand when you look at all three of them at the same time. Then the next stage of this topic is to start to reason and work towards developing formulas for perimeter. And I would start by giving children a sheet that's entirely rectangles. There's one here that'll be free to download in the usual places, and ask them to find the perimeter of all these rectangles. It's a nice opportunity to explore the different shapes rectangles can have and the fact that they can be in different orientations. But the main thing is you want to nudge children towards starting to notice that they only actually need to measure two sides, because they can develop a strategy of adding 2 of the width and 2 of the length, and they're there. They don't actually need to measure all 4 sides. Then we can go through all the steps of developing a formula, which are explained in the video on formulas. Here's a link to that now. But let's just look at them in the context of the perimeter of a rectangle. First of all, children need to explain what's going on structurally in words, and you need to listen to them really carefully, because they might be doing it in different ways from each other, different ways to what you expect. That's the art of listening to the child, not listening for the answer you expect to hear. Because here, some children will add the width doubled to the length doubled, but some children will see this measurement here, a width add a length, doubled, and it's slightly different. And whatever they see, you want to write that down in words and then contract it to a formula where it's really obvious what word each letter is standing for. So this could be P equals 2L plus 2W. That would be fine, but it could also be P equals 2L plus W for the child who's seeing it this way. And hopefully the children will be able to see what each other sees. Then you can find some perimeters using that formula, so you don't necessarily have a diagram anymore. You might have word problems which describe that there's a rectangular shape in the word problem and what the length and the width of it is. And you can also work backwards. You might have problems which tell you the perimeter and the length, and you have to find the width, or the perimeter and the width, and you have to find the length, or the perimeter, and you have to find out what the possible lengths and widths could have been. That's a lovely challenge exercise. And of course you can push children to reason about all the possible answers in a question like that. So just to explain that a little more, if the perimeter of a rectangle equals 20 centimetres, what could the length and width have been? Well, the width might have been 1 centimetre and the length 9 centimetres. That would have worked. Or the width might have been 2 and the length might have been 8 centimetres. Can they find all the answers? Do they have to be whole numbers? Can they describe what's going on? And then you can give children all the two-dimensional shapes we covered in the two-dimensional shapes video. Here's a link to that one now. And ask them, can they find formulas for any of these shapes? Can they reason and develop their own ideas for shortcuts for finding the perimeter? So for example, this regular octagon, P equals 8L, if L is the length of one side. You could look at a parallelogram. You've got twice the base added to twice the diagonal side. and so on. There's plenty to go at. Final thing I want to cover in this video is the trundle wheel. Now, if you don't know what a trundle wheel is, it's a stick with a circle that turns on the bottom, a single circular wheel. And the diameter of the circular wheel is just over 30 centimetres, and it means that the perimeter of the wheel, which has the special name circumference, because that's a special name for the perimeter of a circle, is exactly 1 metre. And there's a little nail on the trundle wheel so that every time it makes one full turn as you roll it along the ground, it goes click. And it's great to use the trundle wheel to measure distances and perimeters of spaces outside. But children really struggle to get what's going on with a trundle wheel because the circular wheel is really quite small to have a perimeter, a circumference of 1 metre. It doesn't look right. It's tremendously helpful if at this stage you can get them doing the perimeter of the wheel on the trundle wheel and get them to truly discover and understand that it is 1 metre, and then get them to do some measuring with the trundle wheel so that every child deeply understands what that trundle wheel is doing. And then, of course, you can consolidate your work on length. So there's plenty of cross-curricular work here, obviously in art, craft and design. In PE, if children are in the field, can you get them to run around the perimeter of the field? Can they find out how long that perimeter is and get a deep sense of that? They might want to measure it with the trundle wheel at the start of the lesson. If you're setting up a pitch, can they find the perimeter of that pitch? Can they measure it? We're going to come back to perimeter in the video on area, because I'm going to explain how important it is and exactly how we set up tasks that compare and contrast area and perimeter. Children have to know which is which and they easily get confused. So I'll be coming back to that in the video on area, and I'll be looking at the dimensionality of each type of measurement in the video on volume. So your takeaways from this video is that children need to work extensively and practically on perimeter to develop a deep understanding of what it is and to consolidate their work on two-dimensional shape and on measuring length. Once they've done that, they should move on to reasoning about perimeter, and that should provide a context for some great work on formulae and a chance to use the strategies explained in the formula teaching video. And finally, children need to learn to use a trundle wheel by measuring the perimeter of the circular wheel with cord and coming to deeply understand what it is, what it does, and how it works. Thank you so much for joining me for this video. If you've any tasks that you'd love to share, please put them in the comments, or you've any suggestions on the video. Constructive criticism, feedback is hugely welcome. Please do take the time to share these videos with your colleagues, with other people that you think would benefit from them, either face-to-face or in social media groups. You're taking the time to become a fantastic maths teacher, and the children you teach are really going to benefit. Thank you for your passion for that. Great maths teachers change children's lives for the better. Bye for now.